I have here a gyroscope, just a wheel and a fairly good bearing, not all that good, but it's not an expensive gyroscope. That wheel can rotate freely in either direction. And I've got a string tied around here. I'm going to pull on this string. When I pull on this string, you might be able to see from the orientation here that when I pull on the string comes around this side of the axle, and that's going to cause a rotation in the which direction? Get the string up here where I can grab it. In the direction around like this. That is, from my perspective, the clockwise direction, so that's a positive rotation. And actually, that's not what I want. I want a counterclockwise rotation, so I'm going to turn the thing like this. Okay, so now that I've got it reversed, it's going to rotate in what I see as the counterclockwise direction. It's going to be easier to demonstrate the vectors involved from this direction than it would have been from the other. Now, when the wheel is rotating, obviously we have an angular kinetic energy and an angular momentum. It's kind of hard to hold this thing and demonstrate. The question is, the angular velocity is in what direction here? Okay, the wheel is rotating this way. Different points on the wheel are moving in different directions. One's moving this way, another's moving this way, while another's moving this way, and another's moving in an upward direction here. Different points of the wheel are moving in different directions in its plane of motion. If we're going to describe this velocity as a vector, which we certainly want to do, just by analogy with regular linear velocity, we're not going to be able to use any vector in the plane because the position in the plane and the direction of motion in the plane is not consistent. We're going to have to use a direction perpendicular to the plane, which is a direction of the axle, this direction or this direction. So as this thing is rotating in the counterclockwise direction, we're either going to want to use a vector in this direction or a vector in this direction to describe its motion. Now the question is, which direction do we want to use? Well, that's arbitrary, but we make a decision based on convention that was arrived at a long time ago, and we use what's called the right-hand rule. We curl our fingers in the direction around, so that the fingers are pointing in the direction of motion, moving around this way. My fingers are pointing in that direction. Now look at the direction of my thumb. My thumb is in a perpendicular direction. It's in the perpendicular plane, and that's the direction of the angular momentum, or the angular velocity vector. Of course, it's also the direction of the angular momentum vector, because angular momentum is the product of angular velocity and moment of inertia. Okay, so angular velocity and angular momentum are both in this direction, pointing that way. Now what's going to happen if I exert a torque on this thing? If I attempt to rotate it while it's spinning in this direction, I'm going to attempt to rotate it upward like this. What's the direction of my torque in this case? Well, my torque wants to produce a rotation like so, in this direction. Okay, what's the direction of that torque? Using the same convention, that torque is going to attempt to move the velocity so that it goes in this direction. Okay, again, rotating around here. If I put my fingers in the direction of that velocity, look at where my thumb is pointing, this way. So my torque is going to attempt to change the angular velocity of this system, which is in this direction, and it's going to influence it in that direction. What's that going to do to the gyroscope? Well, that means as I pull it up this way, the angular acceleration that results from the angular torque and is equal to the torque over the moment of inertia will be in this direction. If I've got a velocity in this direction being accelerated in this direction, what's going to happen? Well, the velocity is going to move in that direction. The velocity vector is here. It's going to want to move around toward here. Now we're going to test and see if that actually happens. I'm going to attempt to pull this string. Okay, here we go. Okay, this thing's spinning pretty good. Now a lot of angular velocity in the direction. Again, think of the direction of my fingers. A lot of angular velocity in this direction. Now I'm going to attempt to pull it up. Look at that, it turns. And the faster I attempt to pull it, more it turns. Let me get it over here, pull it up. We can definitely see, I'm not doing that with my fingers, I can feel that thing just trying to pull itself around to the right. Now it's slowing down a good bit and there's less and less effect, but that's what happens. If I had the thing balanced here, and I'm not going to wind it up again, but if it was spinning here, the angular momentum would be upward